There's a composting method that finishes in just 14 days, not months, just days. 2 weeks from kitchen scraps to finished compost, 2 weeks from waste to the richest soil booster you've ever seen. The compost from this method is different, darker, finer, smelling like forest soil after rain, crumbling in your hands like a chocolate cake. Plants grown in it explode with growth that fertilizer just can't match. This compost is sterile. This process kills weed seeds that would survive regular composting. It destroys plant diseases that would otherwise spread through your garden. It gets rid of the pathogens that make raw manure dangerous. What you end up with is pure fertility, clean life, energy without risk. This method doesn't need any special gear, no drums, containers, activators, accelerators, or any products at all. All it takes is a pile, a pitchfork, and know-how. The kind of know-how the Amish have been using for 300 years. Knowledge their farms rely on. Knowledge that lets them grow food without buying fertilizers, without getting soil enhancers, without ever stepping foot in a garden center. The Amish don't buy fertility. They make it in 14 days. And somehow, in a world where garden centers sell composting equipment that promises results in 6 to 12 months, this method is barely taught to anyone. The fertilizer industry pulls in $200 billion a year. The composting equipment industry pulls in $2 billion a year. Together, they've made sure the fastest and most effective composting method stays hidden from the people who need it most. Today, we're revealing the secret to 14-day composting, the method that makes slow composting a thing of the past, the technique that turns waste into wealth in just 2 weeks, and the industries that profit from you never learning it. If this matters to you, subscribe and hit the notification bell. The case is still open. Back in 1962, a researcher from the University of California, Berkeley, studied decomposition. His name was Dr. Rabbe. He was a plant pathologist interested in how composting kills plant diseases. He needed compost for his experiments, lots of it and fast. The common wisdom about composting was to pile up organic material and wait. Turn it occasionally, add water if it got dry, and harvest after 6 to 12 months. Dr. Rabbe didn't have 6 to 12 months. He had to run experiments. He started looking into what made decomposition fast or slow. He checked the temperatures inside compost piles. He tracked bacterial populations. He experimented with different mixes of materials. What he found went against everything gardeners believed about composting. Speed had nothing to do with just waiting. Speed was all about how you managed it. A well-managed pile broke down in a fraction of the time. From a neglected pile, not just a little faster but dramatically faster, Dr. Rabbe developed a protocol. Specific material ratios, exact pile dimensions, precise turning schedules, specific moisture levels. By following this protocol, his research team produced finished compost in 14 to 21 days. Always reliable, the method worked. He called it the Berkeley Method. But when digging into the history, he found something surprising. The method wasn't new, it wasn't his invention. Farmers had been using these techniques for centuries. Amish communities in Pennsylvania passed down this knowledge through generations. German immigrant farmers brought it over from Europe. Chinese agricultural texts documented similar methods thousands of years ago. Dr. Rabbe didn't invent the Berkeley Method. He rediscovered what industrial farming had buried. Science explains why 14 days is doable. Composting is just decomposition. Microorganisms, mainly bacteria and fungi, break down organic material into simpler compounds. The end product is humus, a dark, stable stuff that makes the soil fertile. In a neglected pile, decomposition happens slowly. Bacteria work on the surface where there's oxygen, but inside it becomes anaerobic, low in oxygen, and decomposition slows down. The pile just sits there for months, only breaking down partially. The Berkeley Method changes this whole process. The first principle is the carbon-to-nitrogen ratio. Bacteria need both carbon and nitrogen to work. Carbon gives them energy, while nitrogen provides proteins for growth. The ideal ratio is about 30 parts carbon to 1 part nitrogen by weight. Too much carbon and the bacteria starve for nitrogen, slowing decomposition down until it stops. Too much nitrogen and the bacteria use it all up quickly and then die. the pile. It gets slimy and starts to smell bad. With the right conditions, the bacteria multiply like crazy, doubling every few hours. Their metabolic activity generates heat, turning the pile into a biological oven. The second key factor is oxygen supply. Aerobic bacteria, the ones that break things down efficiently, need oxygen. In a static pile, oxygen only gets a few centimeters in. The inside becomes anaerobic, taken over by slow-acting bacteria that cause bad odors. The Berkeley Method supplies oxygen by turning the pile frequently. The pile is turned every 2 days and during the active phase, sometimes daily. Each turn moves the material from the inside to the outside and vice versa. Every particle gets time in the oxygen-rich zone. Aerobic decomposition continues throughout the whole pile. The third key point is moisture. Bacteria need water to live and to carry out metabolism. A dry pile is an inactive pile, but too much water fills the spaces. It blocks air and creates anaerobic conditions. The ideal moisture content is between 50 and 60%. The pile should feel like a wrung-out sponge. When you squeeze a handful, 1 or 2 drops of water should come out. The fourth principle is particle size. Smaller particles have more surface area. More surface means more contact between bacteria and the organic material. More contact means faster breakdown. The Berkeley Method requires chopping or shredding the materials before adding them to the pile. The leaves get shredded, the stems chopped, and the big pieces broken down. The fifth rule is the size of the pile. Too small and it can't generate or hold enough heat. Too big and oxygen can't get in even if you turn it over. The perfect pile is about 3 feet by 3 feet by 3 feet. 1 cubic meter, big enough to heat up, small enough to turn. The sixth rule is the turning schedule. This is where the Berkeley Method is quite different from regular composting. Day 1, build the pile. Day 4, first turn. Day 6, second turn. Day 8, third turn. Day 10, fourth turn. Day 12, fifth turn. Day 14, sixth turn. The compost is ready. Every 2 days, the pile gets completely turned over. The inside becomes the outside. Wet spots mix with dry spots. Fresh oxygen gets everywhere. This turning schedule keeps the pile aerobic the whole time. Process. The bacteria never run out of oxygen. The decomposition never stops. Following these principles, the pile heats up within 24 to 48 hours after it's built. Internal temperatures reach between 130 and 160 degrees Fahrenheit. This heat doesn't come from outside. It's generated by bacterial metabolism. Billions of microorganisms consume organic material and release energy. The heat serves several purposes. It speeds up decomposition. The bacteria, thermophiles, heat-loving species, work faster than their relatives in cool temperatures. At 130 degrees F, decomposition happens at its fastest. It kills weed seeds. Most weed seeds die at temperatures above 140 degrees F if kept for several days. The turning schedule ensures all the material spends time in the hottest zone. It destroys pathogens. Pathogens that might survive regular composting die off. Because of the consistently high temperatures, the finished compost is safe to use anywhere in the garden. It gets rid of pests. Bug eggs and larvae can't survive the heat. The compost comes out clean. By day 14, the transformation is complete. What went in as recognizable waste comes out as dark, crumbly, sweet-smelling humus. What usually takes most gardeners a year only takes 2 weeks here. The Amish didn't learn this from Dr. Rabbe. They learned from their grandparents, who learned from their grandparents, who brought this knowledge from Germany and Switzerland 300 years ago. The Amish farming system relies on quick composting. Amish farms don't buy synthetic fertilizers. Their religious beliefs stress self-sufficiency. Everything the farm needs, the farm produces itself. This creates a challenge for soil fertility. Crops take nutrients from the soil. Animals eat feed that comes from the soil, without putting it back. Nutrients, the soil gets depleted. The Amish solution is large-scale composting. Every Amish farm runs active composting facilities. Animal manure, crop leftovers, kitchen scraps, and bedding all flow continuously into the composting systems. If composting took 6 to 12 months, it would need a huge amount of space. The piles would build up faster than they could be used. The farm would be filled with compost just sitting around. But when composting takes only 14 days, the system is. It stays compact. The material goes in, breaks down, and comes out onto the fields before more stuff piles up. Fast composting isn't just a convenience for the Amish, it's a must. Their whole farming system depends on it. The same techniques show up all over the world in traditional farming. In China, farmers have been doing hot composting for over 4,000 years. Ancient farming texts talk about layering materials, keeping them moist, and turning the piles to generate heat. The recommendations match exactly with the Berkeley Method. In France, the technique is called compostage or hot composting. French gardeners used it to get high yields in small spaces. The fertility from quick composting allowed for surprisingly productive results. In Japan, Bokashi composting reaches a similar speed through fermentation instead of bacterial breakdown. The principle is the same: the decomposition. Managed compost beats neglected piles. In India, the indoor method developed in the 1920s by Sir Albert Howard showed the same principles: the right carbon-to-nitrogen ratio, proper moisture, regular turning, and finished compost in weeks instead of months. Every farming tradition that needed quick fertility found the same answer. The principles are universal. The knowledge is old. It's just modern gardeners who were taught to wait 12 months. Slow composting serves specific interests. The fertilizer industry doesn't benefit from gardeners who make their own soil nutrients. A gardener who composts quickly doesn't need fertilizer. They produce soil enhancer faster than they can use it, often giving the extras to neighbors. They never have to buy fertilizer. But a gardener who composts slowly still needs to buy fertilizer. Their compost pile takes a year to mature. Meanwhile, they keep buying products. Being a customer. The fertilizer industry hasn't shut down fast composting through some conspiracy. They just never taught it. Advisory services, often funded by big agriculture, only taught slow composting as the way to go. Publications from groups close to the fertilizer industry stressed the waiting time. The hands-on work needed for fast composting wasn't mentioned. The composting equipment industry had its own interests. A gardener who building a simple compost pile doesn't need any special gear. A pitchfork to turn it, maybe a hose for watering, no need to buy anything. The equipment industry sells drums, containers, aerators, thermometers, activators, and accessories. They want gardeners to think composting needs products. Fast composting doesn't need products, it needs know-how and effort. Neither of those can be sold. The industry pushed equipment-based composting, drums that promise quick results. 4 to 6 weeks, still slower than the Berkeley Method, but faster than neglected piles. Containers that hold materials but don't speed up decomposition. Activators that add bacteria already found in any soil. None of this stuff is necessary. It all costs money. The industry profits from a complexity that doesn't need to be there. The fertilizer and equipment industries together have created a culture of slow, complicated composting. Gardeners used to think quick composting needed special gear or technical know-how. They didn't try the simple methods that actually work. They waited months for results that could come in weeks. The truth is simpler than what we've been taught. You can build a pile using the Berkeley Method today. Gather your materials: brown, carbon-rich stuff like dry leaves, straw, cardboard, wood chips, sawdust, dry grass. These give the bacteria their energy source. Green material rich in nitrogen like fresh grass clippings, kitchen scraps, coffee grounds, fresh manure, and green plant parts. These give proteins that help bacteria grow. The mix should be about 2 parts brown stuff to 1 part green stuff by volume. This gets the carbon-to-nitrogen ratio to 30:1, which bacteria like best. Chop the materials into small pieces. Shred leaves with a lawnmower. Cut stems with scissors. Tear cardboard into bits. Smaller particles break down faster. Build the pile in layers. Start with a 6-inch layer of brown material on the ground. This helps with drainage and provides the initial carbon. Add a 3-inch layer of green material. This supplies the nitrogen that boosts bacterial growth. Keep alternating layers until the pile is about 3 feet tall. Finish with a brown layer to cut down on odors and pests. Water each layer as you build it. The pile should be damp. Completely like a wrung-out sponge. The dry spots won't break down. The pile will heat up within 24 to 48 hours. Stick your hand in or use a compost thermometer. Inside, it should reach between 130 and 160 Fahrenheit. If it doesn't heat up, the pile is too dry, too small, or lacks nitrogen. Start turning it on day 4. Use a pitchfork to move the whole pile to an adjacent spot. The material from the outside goes to the center. The material from the center goes to the outside. Unpack the clumps, add water, and check for dry spots. After turning it, the pile should heat up again within 24 hours. Temperatures should go back into the thermophilic range. Keep turning it every 2 days. Day 4, turn it, the pile should be hot. Day 6, turn it, the pile is still hot. Day 8, turn it, the pile might start to cool down a bit. Day 10, turn it, the pile is cooling more. Day 12, turn it, the pile is getting close to room temperature. Day 14, turn it. The compost should be ready. On day 14, check the material. Finished compost is dark brown to black. It smells earthy and fresh like a forest. You won't be able to recognize the original materials anymore. The texture is crumbly and even. If you still see recognizable bits, keep turning it for a few more days. Some piles are ready in 14 days, others take 18 or 21. Factors like the ambient temperature and what you put in affect how fast it breaks down. Use the finished compost right away or store it for later. Unlike regular compost, immature Berkeley compost doesn't burn plants or strip nitrogen from the soil. You can apply it straight to garden beds, mix it into potting soil, or use it as a top dressing around established plants. Comparing it to slow composting isn't fair. A neglected pile takes 6 to 12 months to produce compost. That compost is often uneven, with some parts not fully broken down and partially decomposed material. Weed seeds survive, and pathogens can too. Keep at it. A Berkeley pile makes compost in 14 to 21 days. The compost is consistent and fully finished. Weed seeds die, pathogens are destroyed. Same materials, same basic process, but totally different results. The only difference is management, turning, moisture, care. 14 days of attention versus 12 months of waiting. Once you know both options exist, the choice is pretty clear. The Amish figured out something we've forgotten. Farming is a association. You work with nature, not against it. You manage biological processes instead of replacing them with chemicals. A compost pile is a biological machine. Billions of bacteria are constantly working to turn waste into wealth. When managed right, the machine runs at full speed. If neglected, it runs slow. The Amish don't neglect their machines. They don't buy fertility if they can make it themselves. They don't wait months for results that come in weeks. Their farms have been running for 300 years without synthetic inputs. The soil gets better with each generation instead of wearing out. The system sustains itself because it works with biology, not against it. Modern farming took a different route. It swapped bacterial fertility for synthetic fertilizer. It replaced compost with bought additives. It traded knowledge for products. This choice created dependencies. Farmers who can't grow crops without buying stuff. Gardeners who can't fertilize without it. Stores, a community convinced that fertility comes from factories instead of from life itself. But the biological machine is still alive. The bacteria that powered Amish farming still live in every handful of soil. The decomposition processes that turn waste into fertility keep working by the same principles. The knowledge was never lost. It just wasn't taught. Dr. Rabbe taught it. The Amish teach it. Ancient Chinese farming texts taught it. Now it's being taught again. This video, the compost pile you build tomorrow could be finished in 2 weeks. The waste you throw away today could feed your garden this month. The fertilizer you buy might be the last bag you ever need. The fertilizer industry hopes you forget this video. The equipment industry hopes you buy their products instead. The system that profits from your dependence hopes you keep relying on it. But a pile of leaves, grass, and kitchen scraps doesn't. Industries matter. Carbon and nitrogen matter. Moisture and oxygen matter. The billions of bacteria waiting to do their job matter. Give them what they need and they'll give you what you need every 14 days. The secret of the friends that was never really a secret. The method buried by the industries that fear it. One orca, one pile, 2 weeks. Fertility forever. If this story has changed the way you see the resources in your garden, subscribe to our channel and hit the bell. We dig up the stories others tried to bury. Let's plant the seeds for the future together. The next nature treasure will be revealed soon.